Before moving on to exercise, we'll once again recall Euclid's 5 postulates. A straight line may be drawn from any one point to any other point. Second one is a terminated line can be produced indefinitely. Third one, a circle can be drawn with any center and any radius. Fourth one is all right angles are equal to one another. Fifth one is if a straight line falling on two straight lines makes the interior angles on the same side of it taken together is less than two right angles. Then the two straight lines, if produced indefinitely, meet on that side on which the angles taken together are less than two right angles. Now we will move on to exercise 5.1. Which of the following statements are true and which are false? Give reason for your answer. First one is only one line can pass through a single point. Suppose if x is a point, then if I ask many children to move on that line, many lines can pass through that point. So this statement is false. So the correct answer is infinite number of lines pass through single point. Second one, there are an infinite number of lines which pass through two distinct points. This statement is false. The true statement is only one line pass through two distinct points. Third one, a terminated lines can be produced indefinitely on both the sides. So terminated means which has end point. So that can be produced both the sides indefinitely, endlessly. So this statement is true. Fourth one is if two circles are equal, then the radii are equal. True. Fifth one is in the figure, if AB equals PQ and PQ equals XY, then AB equals XY. So the statement is true. Define the following. First one is parallel lines. Parallel lines are lines in a plane that are always same distance apart. They never intersect each other and have no common points. The symbol for parallel line is two lines which is written horizontally. Vertical two lines represents parallel lines. The best example is railway track and the ladder. The second one is perpendicular lines. Perpendicular lines are lines which intersect to form right angles. The symbol of perpendicular lines is inverted T. See, in a perpendicular line, when a perpendicular line is drawn, that angle formed will be always right angle. Third one, radius of a circle. Radius is the distance between the fixed point and any point on the circle. It is denoted by small letter r. Next one is square. It is a polygon formed by four line segments which are equal and all the angles are equal to 90 degree. Next one is polygon. It is a single closed figure formed by three or more line segments. Intersecting lines. Two lines which cross or meet at a common point are called intersecting lines. So, in the intersecting lines, when the opposite sides are, they are known as vertically opposite angles, and the vertically opposite angles are always equal. AB intersects CD at O. Here, AOD is equal to COB. They are vertically opposite angles. They are always equal. Next one is concurrent lines. Three or more lines that cross or meet at a common point are called concurrent lines. Here L, M, N, X are different lines which are meeting at a common point. That's why they are called as concurrent lines. Collinear points. Three or more points lying on the same line are called collinear points. Non-collinear points. Three or more points which do not lie on the same line are called non-collinear points. If they are lying on the same line, we call it as A, B, C. All the 3 points lie on the same line. That's why they are collinear points. A, B, C in the next side is they are not lying on the same line. That's why they are called as non-collinear points. Next, consider two postulates given below. Given any two distinct points A and B, there exists a third point C which is in between A and B. There exist at least 3 points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow from Euclid's postulates? Explain. First one, yes, because they deal with two different situations. It says that given 2 points A and B, there exists a point C lying on AB in between A and B. The second one is, it says that given 2 points A and B, there can be a point C not lying on line AB. It is related to Euclid's postulates. Given two distinct points, only a line can pass through it. If a point C lies between 2 points A and B such that AB equals BC, then prove that AC equals half of AB. Explain by drawing the figure. Given C lies between A and B such that AC equals BC. To prove that AC equals half of AB. Proof. AC plus BC is equal to AB. That means AC plus BC coincides with AB. Then AC plus AC equals AB. So because AC plus AC equals BC, that is given in the statement. Therefore 2AC equals AB. So we can write it as AC equals AB by 2 or AC equals half of AB. In question 4, point C is called a midpoint of line segment AB. Prove that every line segment has one and only one midpoint. Given C is the midpoint of AB. To prove every line segment has one and only one midpoint. Proof. Let us consider two midpoints C and D on line AB. Next one is AC equals BC because C is the midpoint of AB. Now we can write it as AC plus AC equals AC plus BC. This is according to equals are added to equals. To AC plus AC will become 2AC equals AC plus BC is coincides with AB. Therefore, we can write as in place of AC plus BC, we can write it as AB. Now, AD equals DB because D is the midpoint of AB. We have considered two midpoints to prove this. AD plus AD equals AD plus DB. Equals are added to equals. Then 2AD equals AB whole length. AD plus BD coincides with AB. From 1 and 2, 2AC equals 2AD. Things which are equal to same things are equal to one another. It is according to axiom, Euclid's axiom. AC equals AD. It is possible only when D coincides with C. Therefore, every line segment can have one and only midpoint. In figure, if AC equals BD, then prove that AB equals CD. Given AC equals BD. To prove that AB equals CD. Proof. AB plus BC equals AC. AB plus BC coincides with AC. BC plus CD equals BD. BC plus CD coincides with BD. Now, AB plus BC equals BC plus CD. Here, AC equals BD given. Therefore, BC and BC you can cancel it. AB equals CD. Equals are subtracted from equals. Then remainders are equal. This is according to Euclid's axiom. Why is axiom phi in the list of Euclid's axiom considered a universal truth? Since it is true for anything in any part of the world. Equivalent version of Euclid's fifth postulate. There are several equivalent versions of Euclid's fifth postulates. One of them is Playfair axioms given by a Scottish mathematician John Playfair in 1729. It states that for every line L and for every point C not lying on L, there exists a unique line M passing through P parallel to L. Considering the following statements, there exists a pair of straight lines that are everywhere equidistant from one another. Is this statement a direct consequence of Euclid's fifth postulate? Explain. Answer is, consider any line L and any point P not on L. Then there exists a unique line M passing through P which is parallel to L. The Playfair axiom, according to Playfair axiom, now the distance of any point from a line is the length of the perpendicular from the point to the line. This distance will be the same for any point on M from L and any point on L from M. Therefore, the two lines are equidistant from each other. How would you rewrite Euclid's fifth postulate so that it would be easier to understand? If a straight line falls on two straight lines, then the two lines meet on that side of the straight line falling on it, where the sum of the interior angles is less than 180 degree when extended indefinitely. Next one is, does Euclid's fifth postulate imply the existence of parallel lines? Explain. If a straight line L fall on two straight lines M and N such that sum of its interior angles on the same side of L is equal to 180 degree, then the lines will not meet on that side of L. Also, we know that some of the interior angles on the other side of L will also be 180 degree. Therefore, the two lines M and N will not meet on the other side of L as well. Hence, the line M and N are parallel and they do not meet. Example, in the figures, C is the midpoint of AB. P and Q are midpoint of the AC and BC respectively. Prove that AP equals BQ equals 1/4 of AB. Now first thing is you have to draw the line on the line AB. P, C and Q are different points. Given C, P and Q are midpoints of AB, AC and BC respectively. Here P is the midpoint of AC and C is the midpoint of PQ and Q is the midpoint of CB. To prove that AP equals BQ equals 1/4 of AB. To prove this proof, C is the midpoint of AB. We have to consider. Implies AC equals half of AB. Call this as 1. Now P is the midpoint of AC. AP equals half of AC. Substituting 1 and 2, AP equals half of, in the bracket, half AB. That implies AP equals 1/4 of AB. Again, because C is the midpoint of AB, BC equals half of AB. Call this as fourth statement. And Q is the midpoint of BC. BQ equals half of BC. Call this as statement 5. Substituting 4 in 5, we will get BQ equals half, inside the bracket, half of AB. That means BQ equals 1/4 of AB. From 3 and 4, AP equals BQ equals 1/4 of AB. In the given figure, it is given that angle 1 is equal to angle 4 and angle 3 equals angle 2, by which axiom it be shown that angle 2 plus angle 4 equals angle 1 plus angle 3. Given angle 4 equals to angle 1 and angle 3 equals angle 2. To show that angle 2 plus angle 4 is equal to angle 1 plus angle 3. Solution is angle 1 is equal to angle 4. Call this as first statement. Angle 3 equals angle 2. Call this as second. Adding 1 and 2, we have angle 1 plus angle 3 is equal to angle 4 plus angle 2. By Euclid's axiom, if equals are added to equals, the whole are equal. Next one is, if C is the midpoint of AB, L and M are midpoints of the AC line AC and BC respectively. Prove that AL equals LC is equal to CM is equal to MB is equal to 1/4 of AB. Also state the Euclid's axioms applied for proving result. Given C, L and M are the midpoints of AB, AC and BC respectively. To prove this, AL equals LC is equal to CM is equal to MB is equal to 1/4 of AB. To prove this, we have to consider C is the midpoint of AB. AC equals BC is equal to 1/2 of AB or half of AB. Call this as statement 1. L and M are midpoints of line AC and line BC respectively. AL equals LC is equal to half of AC and CM is equal to MB is equal to half of BC. That is, AL equals LC is equal to half, inside the bracket, half of AB. That means CM is equal to MB is equal to 1/2, inside the bracket, 1/2 AB. From 1, we have AL equals LC equals 1/4 of AB and CM equals MB is equal to 1/4 of AB. Therefore, AC equals LC equals CM equals MB is equal to 1/4 of AB. By Euclid's axiom, things which are half of same thing are equal to one another. In the given figure, we have angle 1 equals angle 2 and angle 2 equals angle 3. Show that angle 1 equals angle 3 and state Euclid's axiom used. What is given? We have to write first. Angle 1 equals angle 2 and angle 2 equals angle 3. Now to show that angle 1 equals angle 3, angle 1 is equal to angle 2, angle 2 equals angle 3, angle 1 equals angle 3. That means by axiom, things which are equal to same things are equal to one another.